Good morning, everyone, and welcome to this session. So I will be talking about utilization of poultry or byproducts into material conversion. And I will start with some background information. So currently, we use fossil fuel-based feedstocks to produce petrol fuels, and also we use naphtha fraction to make chemicals out of it. This current economy is a fossil fuel-based economy, and there is a lot of interest to transition from fossil fuel-based economy towards renewable, sustainable, or the circular economy. However, transition towards renewable, sustainable, or circular economy, we can use renewable feedstocks compared to non-renewable. Examples are carbohydrates, lipids, and proteins. There are three different types of renewable feedstocks: first, second, and third generation. First generation feedstocks are those feedstocks which are in direct competition of food and feed. Second generation are those which are in indirect competition with food and feed. For example, we use land, we use resources to produce these feedstocks, although we don't use them for food or feed applications. And then there are third generation feedstocks, which can be feedstocks from industrial or byproducts, which do not compete with the food and feed either directly or indirectly. And one example of such feedstocks could be the poultry industry or byproducts. These are third generation feedstocks. We can extract proteins and lipids from there and use them for the production of materials. The advantage would be that we can produce materials which can compete with the existing non-renewable based materials, which are cheap and stronger compared to the current materials. So if we start with the or byproducts, the cost could be less, and therefore there is a potential that we can transition or at least start transition from non-renewable to renewable materials. So I'll give you some examples of activities in my lab. So we are using some proteins and lipids from poultry byproducts. One example is using poultry feathers. So we make sorbents from poultry feathers and use them for the treatment of different waters, contaminated waters, whether those are for oil sand industry or other industries. We also use poultry feather fibers to make composites and nanocomposites, especially for high flame resistance and as well as moisture resistant applications, which are current issues with the bio-based composite materials. We take lipids from spent hens and other sources, convert them into monomers and biopolymers from there. We also take glycerine from this process and convert it into monomers and biopolymer. I'll give you some examples of these and how do we use them. As you know, spent hens are available in really big quantities and can be used for the production of materials. They are as a core byproduct, and so we can use them for the extraction of proteins and lipids. We actually did extract proteins and lipids. We extracted lipids using microwaves. Microwaves are much faster compared to conventional heating because we can extract lipids faster. We were able to get 98% recovery in 10 minutes, and which is much faster. And also, we didn't use a lot of solvents, which is a better process or greener process compared to conventional extraction. I'll give you an example of utilization of these lipids. So lipids are basically these triglycerides. We have this glycerine, which is attached to 3 fatty acids, and we can trans-esterify and make fatty acids or esters from there and then separate glycerine. This is generally process which biodiesel industry does or other industrial processes. Oleochemical industry also does this. So I'll give you an example of direct utilization of triglycerides, conversion of these fatty esters, and also conversion of glycerine. So Starting with the direct triglycerides, we oxidized the triglycerides and functionalized them with the nanoparticles, and then polymerized or copolymerized them to make films for packaging application. You can see here, this is one example. This is a much clearer film, which is most of the time requirement for packaging applications. And we also did use these fatty esters and functionalize them and polymerize them in the presence of nanoparticles to make packaging films. The second utilization or process we used was the olefin metathesis. This process is commonly used in petrochemical industry to produce monomers or chemicals for a variety of different applications. It works well for conventional metathesis process for petrochemical industry. It doesn't work well for the renewable resource-based fatty acids. The reason being that solvent decomposes in organic solvent, catalyst decomposes in organic solvents, and also the catalyst is not really very much tolerant to the functional groups. So what we did is we got rid of the solvent, and we used basically solvent-free process with the microwaves. And here is an example of conversion of fatty esters from the lipids using metathesis process with the help of custom-built microwave to convert them into monomers and polymers from there. Another example is utilization of glycerine. So as I said before, glycerine, we take this glycerine, we convert it into illegal alcohol. It was a faster process within 10 minutes. And then we make monomers from there and produce polymers using these monomers. So here is one example of using illegal alcohol to produce monodiallyl phthalate and then polymers from there. Look at here the thermal stability of the polymer up from 100 to about 300 degrees Celsius. They can be used for different applications. We tried them for consolidation of tailings. I will give you an example and then when we talk about tailing consolidation. So we used these two technologies are patented technologies which were transferred to a new spin-off companies of a Biorefinery Inc. And that is producing material from there. We also used these feather keratin to prepare cross-linked hybrid composites for high thermal stability as well as moisture resistant and flammability applications. And you can see here the moisture resistance was much higher when we functionalized the keratin, the fiber, and made composites from there. The flammability was much lower, so they are flame resistant kind of biocomposites when we compare them without functionalization and modification. The third example, or the example for water treatment, as you know, water contamination is a major issue in a lot of industrial processes, whether that is food industry or chemical industries. So we used feather keratin to make bioabsorbents from there and use them for the removal of different contaminants, including arsenic and different metals, as well as naphthenic acids from oil sand process affected water. I will give you an example of oil sand process affected water or tailing. How does how is that produced and how can be that remediated? So currently, oil sand industry uses water from a river, for example, Athabasca River. That water is mixed with some of the recycled water, and that is used for the extraction of bitumen. So hot water is mixed with the bitumen. After the extraction, that water is separated and put into the tailing ponds. We have big reservoirs of tailing ponds, and that is settled to some extent. We have these tailings at the bottom and water at the top. That water is used again and mixed with the fresh water. So this process, there are two issues. One is to consolidate these tailings, because to remediate the land, we need them to consolidate, and so that we can use it for vegetation and remediation. And secondly, we should be able to treat this water to produce a water which is safe to release into other bodies, or at least for utilization. So these are two major issues, and we tried to tackle them using these feather-based sorbents. So what we did is we converted this keratin into different type of sorbents and used them for the removal of contaminants, metals, naphthenic acids, as well as tailing consolidation. So I'll give you an example of metal removal. You can see here, this is an example of 8 different metal removal using 2 different pHs, acidic as well as basic. You can see we were able to remove up to 90% or sometimes more than 99% of the metals from the water. We also used it for the removal of different metals as well as naphthenic acids from the oil sand process affected water, which are toxic. So you can see there was a much better removal using the keratin-based sorbents. Another example is the poultry feather-based sorbents or biopolymers were used to consolidate the tailings. And as I said before, tailing consolidation is a major issue. Most commonly used polymer is the polyacrylamide, which is a synthetic polymer. It's a expensive polymer. And you can see here in comparison with this polyacrylamide, we have some keratin-based solvents which can consolidate better compared to the polyacrylamide. So we also looked at the percent consolidation in 160 days. You can see here the polyacrylamide can get to about 15% consolidation, and we can get about 35% or so consolidation with some of the polymers which are keratin-based polymers from poultry feathers. Similarly, you can see here the water recovery. Water recovery is much better when we used the polymer based on keratin compared to this polyacrylamide-based polymer. You can see here about 10% water recovery. We can get up to 35% or so, or more than 30% water recovery when we use these keratin-based, feather-based polymers. We also did a scale up on this. Those columns were 250 mils. This is a 10-liter columns using selected sorbents. You can see here, this is palm consolidation is much lower compared to currently we have those optimized sorbents which can give much better, faster consolidation as well as water recovery compared to the palm. We also used those polymers which we produced from glycerine. So here, these are the polymers which were produced from glycerine for consolidation compared to palm. You can see much better consolidation when we use polymers from glycerine as well as water recovery. In summary, so I would say poultry byproducts is a huge resource which can be used for renewable material development. We can produce different type of chemicals, polymers, and sorbents for different applications for the removal of metals, naphthenic acids, and other contaminants, as well as consolidation of tailings and efficient dewatering, remediation, and those kind of applications. So I would like to acknowledge my group members, collaborators, funding agency, and thank you for your attention. I would be happy to answer your questions.
Sorry, folks, I did hit the button. Thank you, Aman, for your presentation. Thank you for joining us live. I remind everybody that if you have any questions, that you can put them in the Q&A box at the bottom of the screen. So, Aman, I have a question. You know, you talked about those sorbents dealing with the tailings ponds and that type of thing, and pulling out the metals. What happens to all of that? Like, where does that go? Does that go into a different stream, or?
The sorbents which we use for the treatment of water, we are now working to desorb metal and reuse them. So we are looking at their reusability, how many times we can recycle. For consolidation of tailings, they will be sitting down in the tailing ponds and at the bottom. That's the process currently used. They use polyacrylamide, and polyacrylamide, there are reports that when it degrades to acrylamide, which is toxic, compared to that, we have this protein. If it degrades to amino acids, most likely we will not have those issues. So for tailings, we don't take it out. For water treatment, yes, we will recycle them and reuse them and see one until they get saturated, then or they are not capable of any more absorption, then we can degrade or digest them and get metals out. So that's the plan.
Okay, cool. I think you've already answered this question, but I'll ask it anyways. Can the sorbents be used in other applications, such as in commercial water filtration devices?
Yes. So we basically initially started with the removal of water, with the removal of arsenic from contaminated water, which is in. We don't drink groundwater, but in some countries, especially in developing countries, people drink groundwater, and that water is highly contaminated with arsenic. That arsenic contaminated water treatment is a major issue. So we started with arsenic removal. Then we expanded it to removal of metals from these industrial waters. And also, I think one of my graduate students presented on Monday, I guess, removal of metals from the poultry water which they use to feed chicks. And so not only water metals, but also we're looking at the removal of pathogens, other microbial contamination. So we are looking at multitude or different type of industrial waters to remove contaminants from there.
Wow, it sounds like an all-around use. What about the source of feathers? Are there enough feathers here in Alberta, or do you have to go far and wide to find them?
So that's very interesting thing, and that's one of the most interesting thing we are excited about. When we compare them, their usage compared to current use, for example, for palm, if you remember when I presented the larger scale trial, the first trial was 160 days because we were using more quantities. Palm doesn't work, or other polymers doesn't work at lower quantities. The feather-based sorbents work very well at lower quantities. So we use in ppm parts per million, smaller quantities, and still they are very effective. So the feathers we have currently, we have huge quantities, and once we make them and use them, we use very small quantities. So we are not, it's not that they are just like a big amount of polymer we put in there and it will settle down. It works differently. They interact at, once we basically, it's a cross-linked protein, we bring it up and it becomes more of a high surface area sorbent. So it can interact very strongly with even at lower concentrations. So we think we have large quantities available. If we can utilize the currently we have in Alberta, I think that should be enough to handle a lot of different water contamination.
Awesome. Well, that's good news for all the industries involved, the poultry industry and beyond.